Okay, so guys, let me talk about law of cosines here. Okay, so let me talk about law of cosines here. There's 3 variations. It seems like a lot of messiness, but I want to start off with something that maybe is a little bit easier to recognize. I'll start with the c squared here. Okay. The nice pattern here is that whatever variable you start with, it's only going to show up at the end. So you're going to be bookending with c, lowercase for the side, uppercase for the angle. Everything in between is going to be the other letters. Okay, so the only time you're going to see whatever letter you start with is going to end with that letter. Now, I'm going to write this here. Once we establish that, okay, do you recognize this? What does that remind you of? Yeah, Pythagorean theorem, right? So this is a Pythagorean theorem. So this Pythagorean theorem worked into this equation, this formula. It's a triangle. It's not a right triangle, so there's more things to it. But at least this is recognizable, right? If you know c squared equals a squared plus b squared, you've started off one of the forms of law of cosines. Now the rest of it is just going to involve what you put here. Okay, so it's going to be minus 2ab and then cosine of c. Okay, so if you can create one variation, then the other variations I think will come pretty easily. Let's start with a. So if I have a, I know I'm going to end with uppercase a. Everything in the middle is going to be just involving the other letters, b and c. So I can say a squared equals b squared plus c squared minus, and then you're only going to involve the letters that you just wrote down. Okay. If you have this, you can also build the other one. You know, if you start with b, you're going to end with b. So very similar kind of Pythagorean theorem-ish, but then you're going to involve only a and c in between. Okay, so I think after today and tomorrow and the weekend to practice this, I think you guys will have this down, okay, without too much trouble. Okay, so the next thing I want to do is I want to make sure that by looking at a problem, can we recognize whether to use law of sines or law of cosines? Okay, so let me review again. If your triangle gives you 2 angles, you know that you have an easier problem. Okay, it's just law of sines. You were able to handle these types of problems on the check-in quiz without any issue. Many of you guys got hundreds on those. So if you see 2 angles, you know it's going to be easy. It's going to be law of sines. Just set it up and then find the missing side. And then you can quickly find the missing angle by just subtracting from 180. Okay, so no issues here. So if you see 2 angles, you know it's law of sines. It'll be an easy problem. The other type is side-side angle. Okay, so side-side angle is where you have an angle, a side, and this hanging side across from your angle that we're going to have to kind of understand by figuring out that vertical height. Okay, so there's this ambiguous case where if this hanging side is more than the height but less than this hypotenuse, it's going to create 2 triangles. And we're going to have to solve both triangles. However, this is only a law of sines problem. So you can get to the answer just by using law of sines, nothing else. Okay, maybe multiple variations of law of sines, but law of sines will get you to your answer. Okay, I think these are the most difficult types of problem. And so we'll practice today going through it very slowly, making sure that, that you guys can understand each step, and I'm going to ask you guys to, to really ask questions if you're stuck. Okay, so we'll go through. This is I think the most difficult variation. Okay. Now, the other types are side angle side and side side side. So if you see side side side, that's easy. Okay, that you don't even have to look at the triangle. You know it's going to be a law of cosines. Okay, so if you see side side side, target the largest angle, because the largest angle is going to be across from the longest side. So whatever the longest side is, that's going to tell you where to start. That's going to tell you which formula to use for law of cosines. Okay. And the other type is side angle side. I want to make sure that you guys see the difference between side angle side and side angle. Side angle side, your angle is nicely tucked in between two known sides. Meanwhile, side angle doesn't have that, right? It has the angle, it has a side, it has a side. It's not between two known angles. So can you guys see that? Oh, sorry, it's not between two known sides. So I think the first important thing is, can you guys spot the difference between side angle side and side angle? Okay, because if you can, then you know instantly which rule to use, right? If you see this, you're going to use law of sines after you go through that ambiguous case test. If you see side angle side, you know you're going to start off with law of cosines. Okay, whatever angle is given, that's the angle you're going to use. If I have angle A given, I want to use the one with angle A. Now, even though this is law of cosines, we're only starting with law of cosines. Law of cosines gets that first missing piece that we need, and then the rest of the problem we use with law of sines. Okay. Some students were asking, can I use law of cosines for everything? You could. It's just a little messier, and we tend not to use law of cosines until we have to because of the messiness involved. Yes.
So for the A thing, it has to be, so the unknown side should be greater than the H value and less than the other side?
Yes, greater than the H, less than the other side. That's how we know that there's going to be two triangles.
Right. But if it's, so when would it be one?
Good. If it's exactly the same as your height, then it's going to be one right triangle. If it's greater than the hypotenuse, it's also going to be one triangle.
What angle?
We don't have a rule for. Oh wait. Yeah, angle. We don't have a rule for that because it's a similar triangle, but the dimensions can be. We don't have enough to know the missing sides. Yeah, so there's no angle. Because it can be scaled to all different sizes, and we don't know if we don't have a side locked in. We have no idea what the other two sides will be. So okay, so if this side is less than the height, then this is going to be free swinging, and there's going to be 0 triangles. So we always want to compare with the height, right? We'll do a full example of this, but yeah, that's a good question. Hopefully that answers some of your question.
So if the hanging side is greater than the underside, so would it be a right triangle or just what I call one?
Just a normal acute triangle.
Okay, and then if it's the same one as the height, it's a
right triangle, one right triangle.
You could use the Pythagorean Theorem.
Yes. And if it's greater than the height but less than the hypotenuse, then we got to worry about two triangles, and we'll do one of those examples. Okay. Okay, so if you guys can go to page 17. Okay, and let's go ahead and draw our triangle here. Okay, so number one. Oh, by the way, when you reach number 4, it's going to be a little bit longer problem. I don't know if I spaced it out on my copy just in preparation to show you the steps. But if at any time you feel like it's a longer problem, like number 4 or 5, feel free to use a separate sheet if you like. If the room is not, if there's not enough room on your handout. Okay, so number 1 and 2, we're not going to solve the triangle. We're just going to determine how many triangles there are. So we have triangle RST. I'll go ahead and draw an angle R. T is 35. All right, what type of triangle is this? Good, side angle. Side angle, this is the only time you have to worry about whether there's ambiguous case. If it's other than side angle, you know it's always going to be one triangle. You don't have to worry about it. You only have to worry about ambiguous case with side angles. Okay, so I'll mark that down, side angle. Which means we have to go through the trouble of finding that vertical height. So let's drop that vertical height down. h. Okay? We got to use sine to figure out what that height length is. So sine of 61 equals opposite over hypotenuse. Cross multiply, solve for h. Okay, everybody with me so far? H equals 30.612. Now, this is not part of our triangle, but it is going to be helpful to help us determine what's going to happen with that 31. So, what do you notice? Does 31 sit between 30 and 35? It does, so it has, so it could end up sneaking into this side here, which means that there's two triangles. So anytime your hanging side is longer than the height, but shorter than the hypotenuse, there's always going to be two triangles. Okay. So right now, this is as far as we need to go. We'll do the full example when we get down later to this page. Okay. Are we okay with that? Okay. Let me just do a couple more instances just so we can flesh out the rest of this scenarios here. What if this 31 was a 29? No triangle, because it's just going to kind of hang free, right? It's never going to reach this end because the shortest distance is going to be 30, so it's not ever going to reach the other side. Okay, so 29 would be too short because it needs to be at least a length of 30. What if this was 36? One triangle, it'll just hang out here. It's too long to be over here. It would just be out here. What if it was exactly 30.612? One right triangle. It'll be exactly that vertical height. Okay, so those are your scenarios. Okay. All right, let's try number 2. 95 degrees. This is going to be obtuse. Now, this is also what? This is also side-side angle, but this is easier because why? Yeah, this is obtuse. So if it's an obtuse triangle, there's no chance that it could be two triangles. You're only going to have this special ambiguous case if there's an acute triangle and all these things have to line up. If it's obtuse, all we need is this length needs to be longer than what? Longer than 9. That's all it needs for it to create one triangle. If it's 9 or less, then it's 0 triangle. So the only chance that with this 95 degrees and the side-side angle, it's either 0 or 1 triangle. We're not going to have two triangles to worry about. Okay, so 19 is greater than 9. That's safe. Okay, so let's look at number 3. Okay, let's go ahead and label everything that we can. Now we're going to be solving it. Okay. Draw your triangle. You have 114 degrees. Oops, sorry, 114 here. Angle A. I'm sorry, not S. I was looking at the previous problem. All right, what category do we put this under? Side angle side. Okay, so put that down. Which means we start with what if you see side angle side? Law of cosine. Good. Okay. I want to make sure that we can see that distinct difference between side angle versus side angle side. This one, we just go straight to law of cosines. Okay. We know we have to involve angle S. Now, we're used to our formula involving A, B, and C's, but it's okay. We can create our own formula using these variables. Okay, so let's build our law of cosines. We know that we'll begin with S and we'll end with S. And then everything in between will be involving R and T. Okay. So the nice thing about side angle side with law of cosines is that everything is going to fit nicely on the right side. We're not going to have to rearrange a whole lot of stuff. Everything is going to be nice for us. And also, if it's side angle side, if it's not side angle, we know there's no worries about the second triangle. Okay, you only have to worry about second triangle if it shows up with side angle. Okay. So as soon as you see any other variation besides side angle, you can cross off that second triangle. There's no need to worry about that. Okay, so let's fill everything in. The nice thing also is that you can enter into the calculator all in one go, but careful though, protect that last piece with a set of parentheses, otherwise your calculator is not going to know order of operations that you want it to know. So have that set of parentheses as you are involving that last multiplication set. Okay, let's practice entering that in. Okay. Parentheses. Make sure you're in degree mode. It's a pretty large number, but we're going to be taking the square root so we can get from S squared down to S. Okay, are we okay so far? Once you apply law of cosines once, the rest you're going to be using law of sines. Okay, are we okay so far? Side angle side, law of cosines, parentheses around that last set. I want to make sure you guys practice entering this in so that you're getting that answer and you're not getting thrown off by order of operation issues. Okay, so now we can move on to law of sines because you have a perfect pairing between side and angle for angle S, for variable S. We just have to either solve for angle R or angle T. So when you do law of sines, you can either have your angle sine A, sine B in the numerator, or you can have the sides in the numerator. If I'm trying to find an angle, I typically like to have my variable in the numerator. It just makes it a little faster. Doesn't have to there's not as much rearranging. But if you're comfortable with your size being in the numerator, that's fine as well. You're going to get the same answer. Okay. So I'm going to target R first. If I can get angle R, then angle T will be easy. All right, everybody okay with the setup for law of sines? Okay, cross multiply. To get sine R by itself, remember, anytime you're trying to solve for a missing angle, you have to involve inverse sine or inverse trig, or I guess in our case, just inverse sine. If you want, you can enter all that mess in here and just enter it all in the calculator. Or if you want to split it up, get that decimal value first, and then do second sign, second answer, and then you can do it split into 2 steps. So it's up to you. Once you have angle R, then that last angle should be pretty easy, right? You know that all angles inside a triangle adds up to be 180. Okay, questions with 3?
When we put them up,
We put the missing information that stems from our triangle.
all right.
We know that this is not a side-side angle.
Excuse me, Russian.
Yes,
Can I have Carly Ritchie at that, please?
sure. We know we don't have to worry about that second triangle because it's not a side-side angle case, right? If it's side angle side, just cross out that second triangle. Good. Questions there? All right, number 4. Okay, what are we looking at here? Side-side angle, right? So we know we have to consider the possibility of 2 triangles if you see side-side angle. So we got to drop that vertical, get that height, and let's see if we can make a decision as to what's going to happen with that 26. Is it going to hang free with 0 triangles? Is it long enough to sneak in to create that obtuse triangle, to create 2 triangles? Or will it just be 1 triangle? Okay. So use sine to solve for h. Sine equals opposite over hypotenuse. Okay, 11.069, 26 and 34, what does that tell us? How many triangles? 2. Yeah, 26 is longer than 11, but shorter than 34, so it has a chance of sneaking into this area here. So we have 2 triangles. Okay, let's do the more obvious triangle first. The more obvious triangle is the one that's in the cute triangle here. So I just want to kind of show you that I know it's kind of stressful dealing with 2 triangles, but what I want to show you is that if you can get that first triangle down, that second triangle will be a lot easier. Okay, it'll be a lot easier. The effort that you put into the first triangle is not the effort that you have to do for that second triangle. You would have most of it figured out if you can get that first triangle down. Okay, so let's do that first triangle. $34 is H, 26. All right, so it's a side-side angle. You only have to use law of sines. Okay. What do we start off with? What do we want to target? Good. You see we definitely have to involve P, but we also want to involve H because H at least has some information, right? We don't want to do K because K has too little information. So we want to solve for angle H using law of sines. All right, so let's set up for H. I'll say sine of H over 34 is equal to sine of 19 over 26. Cross multiply, let's get that sine of H by itself, and then we'll involve inverse. Get that decimal value, or if you want to enter it all into one go, you can. Or you can find this decimal first and then plug it in here. $25.197 or 198. Okay, so we have that angle figured out. Okay, so if I have 2 angles, that third angle should be easy. Subtract from 180. Let's find that angle K. $180 minus 19 minus 25.198. And now I still need to look for that missing side K, so we want to involve law of sines again. Cross multiply, solve for k. Enter all that into your calculator. Let's see, 55.673. Okay, so we have one triangle down. We have another triangle to go, but I want to show you that the second triangle will be easier than what you did with the first triangle. Any questions with the first triangle? Okay, now the second triangle, we know that this hanging side is going to sneak over here. It's going to create an obtuse triangle. So go ahead and create that obtuse triangle. Label P, H, and K. And I want to show you how this connects with the previous triangle that we just built. There's going to be a certain relationship here between the H that we're looking for and the H that we just found. We know that they're not the same angles, right? One's acute, one's obtuse, but there's an easy relationship between these two. What is it? They're supplementary. So if I know that this is an acute angle, I know I can always find this other obtuse angle by just subtracting from 180. Okay, so I want to make sure that you guys see that connection, because that's what's going to make this second triangle a lot easier if we can understand how to get to that angle H quickly. Okay, are we okay with that? Okay, so So 180 minus 25.198, I get 154.803. And now we can fill in the other sides, and this is going to feel like a pretty easy problem using law of sines. Okay, this is after we get this filled in, it'll be just like solving for one of the problems on your check-in quiz. Okay, so we have 19 degrees here, 34, and 26. So the nice thing about this is that you have two angles figured out already. You just have to find that third angle, and the law of sines wants to get that missing side k. Okay, so subtract 1 from 180. Angle K, 6.198. And now law of sines will take care of that last piece that we need. Cross multiply, solve for k. Okay, questions here?
Wait, so how do you get the 150?
Oh, this 154.803. it's because that angle H between the two triangles, these two angles have a special relationship. They're going to be supplementary angles. So this acute angle is going to help connect us to this obtuse angle by just subtracting from 180. Yeah, so that's really going to, yeah, you really want to take advantage of that, because otherwise that second triangle is going to be a mess to figure out. You really want to use that as a connecting thread to make that second triangle a lot easier to solve. Yes? Question? Yes, that's right. You can use H. It's just because I already involved P, so I just carried it over. But yeah, you can use anything you want with that last missing piece remaining. Good. Any questions here? Okay, let's do one more problem. And this is number 5. Okay, last one here, number 5. Okay, does anybody still need this? Okay, number 5. Triangle CAB, side A, side B, side C. Even without looking at the triangle, you know this is going to be a what? Side, side, side. If it's side, 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 you're going to use what? Law of cosines. Okay. All right. So I'm going to draw a triangle here. Where do we start? Good. Find the largest side, find the longest side, and that will lead you to the largest angle. Okay, everybody good with that? Law of cosines, side, side, side. Now, I will say that we know the ambiguous case is the most difficult problem. It's the messiest one. I would say this is the second most difficult one, just because, I mean, we're using law of cosines, but the problem is that you're trying to solve for that angle, and we can't just enter into the calculator in one go. We have to kind of split it up. So it's not as clean as side angle side, where everything is nice on the right side. You can just put everything in. We got to do a little bit of rearranging, and it's not going to be as quick as side angle side. Okay, so we're going to find the formula that has angle B in it. We're going to enter everything in. And I want to show you that because we're finding angle B, it's not going to be as quick and easy as side angle side. Okay. All right, here is what we got to be careful about. When I was walking around last Friday just to see how, or last week when I was seeing how you guys were trying out these problems, this is what I saw. A lot of students want to enter all this into the calculator. They're like, well, these numbers are together. Why can't I just put them all in? These, we want to make sure are different than these right here. Okay, these numbers look like they're free to combine with this, but that cosine of B is unresolved. So this is attached to cosine of B. We can't merge these together. So here's our strategy. We're going to move these single terms kind of away from the right side. We'll clean this up down to a coefficient value in front of cosine. Then we'll divide this over, and then we can involve inverse cosine. Okay. I know it's tempting, but we can't enter all this into the calculator at once. There's just order of operations is preventing us from merging all this mess together. Okay, so my first thing is I'm just going to just worry about moving these terms to the left side. Okay, your goal is to get B by itself, so piece by piece, you're going to move the easiest things away from it, and then we can worry about the multiplication terms. So 28.9 squared minus 24.1 squared minus 28.1. All this is going to be okay, so I just subtracted the 24.1 squared, 28.1 squared, and I got negative 535.21. Okay, the next thing is we want to multiply these together so that we have a nice clean coefficient in front of that cosine of b rather than this mess. So 2 times 24.1 times 28.1, that's going to give us okay. Do we see the flow of events here? Okay. Move things, all your single terms away from the cosine, and then clean this up. And finally, we're going to divide. We're going to divide this over, get that cosine b by itself, and then do inverse cosine. Enter into your calculator. We'll get 0.39515. Okay, so now we can involve inverse cosine to get that angle B solved. And by the way, this is side, 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 right? So we have no issues with that second, no worries about that second triangle. We can eliminate that. Okay, so we have angle B, 66. So as soon as you apply law of cosines once, you're going to transition over to law of sines. All right, so law of sines, I'm going to solve for angle A because I've got a perfect pairing for B, and I have something for A, so I'm going to solve for angle A. Once I find angle A, angle C should follow easily with two angles found. Okay, so I'm going to set up to solve for angle A. Get sine A by itself and then involve inverse.
Good afternoon, Milton Eagles. The following are the bus change announcements. Students who ride bus 4515 will now ride bus 4090. Students who ride bus 443 will now ride bus 442. In a few minutes, we will be conducting a fire drill for all staff, students, and teachers. Please bring your belongings to be dismissed by the teacher after the drill to go home. Have a good afternoon.